Ew.
Good evening.
That's Monaco.
That's milk.
Sayonara.
Senor Leches, man.
¿Qué pasa, chico?
All right, we're hitting you up with some learning targets about nuclear shielding. One of my favorites, because it explains all the trends.
Should we just go have a seat and let him do this one?
I could do it quick, but I do want their help. So, nuclear shielding is the way that the exterior electrons, the valence shell electrons, feel.
I'm going to shield
The
myself
nucleus.
from the Monaco.
You feeling me? Is what the electrons are saying to the nucleus, and the nucleus is saying to the valence electrons, like, you feeling me, bro? Feeling me, bro? And the answer is, it can be calculated. And if it's yes or no, effective nuclear charge is the you feeling me, bro? Okay? And this is how we figure it out. We have to look at Z effective, which is defined as effective nuclear charge. Z is the number of protons. So on the right-hand side of this equation is the number of protons. So that's the number of positive charges in the nucleus. S is the kernel electrons. So all the electrons between the outer electrons and the nucleus. So the nucleus, again, is talking to the outer electrons and saying, you feeling me, bruh? And all the kernel electrons are in the way, running interference, shielding the outer valence electrons from the nucleus that is saying, you feel me, bruh? And so let's see how it all works out.
So basically, in other words, it doesn't matter how many positive magnets we get in the middle. If we have a ton of interference between them and the outside, maybe not.
We not feeling you, bruh. We don't
Not
understand.
like we should.
So causes and effects. Simply put, as you go across a period, shielding decreases. So the nuclear charge increases while the number of energy levels and kernels electrons stay the same. So as you move further to the right across the periodic table, the effective nuclear charge is increasing.
Yes. So
Okay?
think about that nuclear charge. We've done this. We know it's the number of protons, the things with the charge in the nucleus. As I go across, I'm adding those, and there's no more interference. So they do their job better. They are more effective.
Because while you're also adding electrons, the electrons that you're adding are in the valence shell.
Right.
So the nucleus that has increasing and increasing and increasing positive charge is louder and louder and louder with respect to the valence shell. So when it says, you feel me, bro? The valence shell is like, for sure. The closer you get to the noble gases, the more and more you feeling me, bro, works out.
Right. And this actually explains one of the important trends that doesn't go like it should.
Exactly.
It's the one that goes weird. So remember that for next video. We're going to set you up for understanding how those trends work.
Okay. I think we're going to go down a group. So as you go down a group, shielding increases because while you do have more nuclear protons in the nucleus, you also have more and more and more levels of electrons. So when the nucleus shouts to the valence shell, you feeling me, bro? That valence shell is further and further and further away. So the effective nuclear charge is decreasing as we go down a group.
Even though we're adding protons
and electrons.
It's because we're adding that whole level of electrons. We're not just adding electrons to the outer shell now. We're adding a whole layer, a whole other shell.
So those electrons are getting further and further and further away. So when the nucleus goes, you feel me, bro? Electrons is like, what? And this is leading to lots of different trends and properties, which is our last video of the unit.
And it is, and it's the most actually important. It's the home run for the unit.
I threw in some practice for nuclear shielding to try and get you to see it on paper.
Yeah.
So if you get stuck on this, please ask us to do those practice pages with you because we're not going to throw a bunch of examples on this particular homework.
No, well, that equation was pretty mad easy.
Effective is you take the protons minus the shielding kernel electrons.
Yeah, we just need to know that kernel electrons is all the inside electrons.
Exactly. And the picture shows you that.
It does.
So there it is.
Good. And I think maybe.
Yeah. I push the button and I turn it off. Yeah. I'm pretty sure they can't hear me.